Good afternoon, everyone. How are you doing today?
Good afternoon, sir. I'm fine.
Good evening, sir.
How are you? All right, so allow me to welcome you to Integrated Math. I would have met some of you at our information session on Thursday, I believe, of last week, and I'm happy to see you guys joining. Are there any questions or any concerns that you want to put on the table as we try to get some housekeeping out of the way? Hello?
No, sir.
No questions, sir.
Okay, good. All right. So as per usual, whenever I'm meeting a group for the first time, I will go through and talk about some things that I don't want to see happen. Talk about the things that I do want to see happen. I want us to be on the same wavelength. I want to be able to understand you, my students, and I want my students to be able to understand me, the instructor. And as a result of that, I will just want to spend a few minutes to just do some housekeeping. Now, the first thing is that this class is not a lecture where you sit back, relax, draw for some popcorn and soda, and just listen to my show. That is not it. It is going to be an active class. When I speak and I ask questions, I want to hear my students unmute and talk to me. I'm not here for any demonstration, any show. No, I'm here to be the facilitator of this class in integrated mathematics. I'm coming to the class with some knowledge. I'm going to be imparting the knowledge that I have to you. You are going to be developing the knowledge given by doing your own research. And by the end of the class, you should be better than I am. So when I'm teaching, I expect students to answer me. Now, here this is the thing. It's a funny little sting to it. If I call upon Ricardo, can you answer this question? And Ricardo is not responding to me. And I call on Ricardo 2-3 times. Best believe that I'm going to put Ricardo in the waiting room because Ricardo is not in my class. All right? When I call upon you, you're going to unmute. I'm not here for right answers only. All right? I also want to hear the incorrect answers because it gives me an opportunity to undo some of the misconceptions that you, the students, may come to the class with. All right? So when I call upon you, I really want you to answer. If not, I'm going to assume that you're not here and just put you into the waiting room. All right? Now, the other thing is respect is due. I am not interested who you are, where you're from. I'm just saying that respect is due. I will give you respect, and I expect to get the respect in return. The rudeness will not be tolerated. I know you guys are year 2 students for the most part. I may have some year 1 here, but rudeness will not be tolerated in this class. And we're going to be spending an academic year together where it is that it will become a very fruitful one. Me being the facilitator, you being the students, and we're working in that sort of relationship where we can both understand each other and to do very well at the end of the school year. Up to when I spoke with you on Thursday, I believe it was, of last week, I it wasn't confirmed that I'll be down for the teaching of this class. There are two groups, but I suspect that this one is mainly STEM students, as the other classes, the other class. You'll have clashes if you were to go to that one. When I give you homework is to be done. I'm also very cognizant that you're not only doing integrated math, but you're doing so many other subjects. But when the homework is to be done, the homework is to be done. The homework is that sort of formative assessment that may not necessarily go towards the final grade, but it gives you an opportunity to concretize what was done in class. As I was saying earlier, I only learned over the weekend, well, after the meeting on Thursday, that I'm going to be down for this class. And as such, I have been trying to put some notes together. So it is that we can, together have something to work with. All right, so what I will do, I use a combination of Microsoft Word, or for better yet, when I'm sending the notes, I will send it as a PDF, and I also write on my screen. For tonight, I am not in the mood to write. I have been doing a lot of preparations for you, so I'm just going to project what it is that I have prepared. Yes, I will project the math that I prepared for you, and we will have, hopefully, a fruitful class tonight. I know you students, and I'm giving you all the things all at once. Having worked on your timetables, I know what your timetables look like. I know for those of you who are doing the sciences, chemistry, and bio, you would have had a full day today. But one of the things that I am very serious about, I am very aware of, I too was a student. Well, back then was a faculty of Pure and Applied Sciences. Now it is Science and Technology. And I'm going to say to you, students, this academic school year, when your timetable is looking the way it looks, is good preparation for the university life. Either you're going to go to med school, you're going to go to engineering, you're going to go to science and tech, you're going to go to Norman Manley. Once it is that you're doing those heavy-based courses, or you're going to go to nursing, it is going to require, or pharmacy, it's going to require back-to-back classes. So I don't want to hear in complaints say, Lord, I can't manage. You're science students. And as a scientist, this is one of the things that we have to learn and learn from now. I promise you, my students, once you get to the university, you will recognize the hassle of moving from one class to the next. You don't get lunchtime. What you have to do is be very creative. I remember days when I had hours of labs, I had to be very creative, run outside, drink a bag juice and eat a biscuit and go back inside and refresh up. All right, food is not allowed in the lab, so you couldn't eat in the lab period. So we have to be very creative in doing what we're doing. And I'll give you a tip. Now that we're online, I would suggest those days that you have heavy classes, that you get up early in the morning and you prepare your lunch. It could be a sandwich, it could be something. You prepare something that, when you can get a break, you can actually eat in between. And when you come back to the face-to-face class, I would suggest that you do the same. I had to carry lunch on those days for the most part when I had long hours, so that at least I have my food with me. I don't have to go and join line to the cafeteria, because that is when you eat up your time that you have to spend. So for now, that's what I have to share as the situations come up and I have to deal with them. I will let you know, and let the class know, and then we can move back on. So I have said a mouthful. Are there any questions relating to what it is that I have said? Any questions, any concerns, any agreements or disagreements? Let me hear from you.
Excuse me, sir. Is class going to be 5:30 every day or just today?
No, man, just 2 days for the week, Monday and Friday.
Oh, what I'm asking is the timetable said 5 o'clock, so I'm wondering if we should change the time.
Oh, it says 5 o'clock?
Yes,
oh,
it
no.
did.
All right. Do you do chemistry? No.
Yes.
But, chemistry was 3 to 5 today, right?
Yes.
Yeah, man. We can't have it at 5 o'clock. So
Okay, thank you.
yeah, man, it's 5:30. Yes, give that a little time to just cool off. Any other question?
No, sir.
All right, good, thanks. Okay, so by raising your hands using the raised icon, I want you to indicate those of you who are year 1 students. Okay, so thank you. I am assuming then that all the others are year 2.
Sir, that was an accident, sorry.
Oh, that was an accident?
Yeah, accident, sorry.
All right. Kesana, is that an accident too? Henry, are you second year?
Yes, sir. I didn't raise my hand.
Oh, it actually came up. Oh, sorry. Green, are you second year?
Yes, sir.
Okay, so you're all second year students then. All right, great. Again, let me just extend my congratulations to you all and just tell you, say, if you ever get a grade 2, you feel integrated maths here and I forgot to do it over. All right, I'm expecting to get all ones in this class. Do we have an agreement?
Yes, sir.
Thank you, Miss Natalie. You will get a grade 1. I'm waiting for the rest to answer me.
Yes, sir.
Thank
Yes,
you.
sir.
All
Yes,
right.
sir.
Yeah, man. Yeah. That's what I want to hear. That's what I want to hear. Yeah, man. So I'm very serious, right? So I really want you guys to be working very hard. So as I said before, I looked at the syllabus today, only today that I had a look at it and had quite a number of variables to work with and looked at it and said to myself, at this, sure, easy 1, 2, 3. Right? Literally, we have 3 modules. Module 1 talks about foundations of mathematics. Module 2 talks about statistics, and Module 3 speaks about calculus. Right? And Module 1 is the longest of them all, containing 8 units. And I'll just start with one of the units on logarithms and exponents, and we'll just have a nice conversation on that. Okay. Okay. All right. So I kind of hinted at it. All right. So let me tell you where I have my limitations now. My limitation, guys, is monitoring the chat while I'm teaching. So sometimes you may put something, a direct message or to everyone, and I am teaching and not seeing the message. So I'm going to ask that you help me out in this regard. So I'm telling you my weaknesses. I'm going to ask you to help me out in this regard. So there is a question, sir, G's and P's, why the class after the 6 o'clock to 8 o'clock? All right. So I am sure that this is going to be raised in our executive meeting come tomorrow. And this is just the honest and true response. Now, based on what it is that we have for the associate degree in CXC, it is very prescriptive. Now, in years past, you can just decide to come studies chemistry, biophysics, or math, chemistry, bio, and you move on. Now, CXC is saying that you must complete 8 units and of the 8 units, 2 complete units in it in order to be awarded the Associate of Science in your respective disciplines. Either you're doing environmental science, you're doing natural science, environmental and life sciences, whatever it is that you're doing. The truth is, you will recognize and agree with me that your classes are all 6 hours long compared to those of your classmates that are in liberal arts, that will get like a 4-hour course. If the course is a practical course, they may get 5 hours, right? So all the science courses are 6 hours long. Now, there are so many courses that we're talking about. Chemistry, biophysics, both units, math, both units, environmental science, both units, geography, both units. Then we talk about the integrated math. Then we're talking about CART studies. We talk about studies. So there are quite a number of courses that we have on, and as a result of that, what we have to do is some of the lectures for one of the units is, or I should say, 1 or 2 of the lecturers will teach both units 1 and 2. So for example, Mr. Emmanuel, the physics classes will have to go at separate times because he is a K physics lecturer for both units 1 and 2. All right. So as a result of our 6-hour courses, we don't have enough time. We don't have enough hours between 8 o'clock and 5 o'clock to put all those courses in play. Really don't have enough time in order to do that, or else we're going to be having clashes. And the kaleidoscope of courses that students are doing makes it even more difficult. So some students may say that they want to do chemistry and bio, but decide that they don't want to do the physics. They may do geography as the other elective because they've got a grade 1 in geography and whatever else the situation is, or maybe do environmental science. It means that for each class, you're going to have 3 times 6, 18, plus 4 hours plus 6 hours for integrated maths. We're talking about 24 hours. And if some of you are doing not but CARP studies or communication, that's another 4 hours. So you talk about 28 hours worth of classes. We cannot fit those times on the time, and it's 28 hours times 2 for unit 1 and unit 2. So talk about 56 hours. We don't have 56 hours between the 8 to 5, because we recognize 8 to 5 is a 40-hour 8 to 5 week, and I just came up with 56 hours. So we really don't have enough time. So as a result, unfortunately, no, the truth is, right about now, I don't really want to go whole asleep. But the truth is, by the time we start class, this too shall pass. You need to recognize that your brain is going to be alive and well. And I will stop the class just before time so that, you don't have to, I can find out from you how things are going. And I want us to share an honest relationship. If it is that I'm moving too fast, say to me, sir, slow down. If you're not understanding, don't leave my class and frustrate yourself. However you're feeling within the class, let me know. If you're feeling good and you're learning, boy, sir, no, so I'm learn a topic here. Let me know also. I just don't want to hear the negatives. Yes, Miss Fox, there is an IA component to this course, but I'll get into that a little later on. Are there any other questions? Oh, sorry, before I do that, Heinz, have I answered? No. Kisana, unmute for me, honey bunches. Heinz? Miss Heinz, can you unmute for me, please? Let me tell you something now. You see, at the end of the class, I am going to call upon you to ask you to assess the class at the end of it. I am not interested, honey bunches, to teach bright students, because when I teach bright students shortcut it and end it in a grade 2. The ones who are meticulous and take them time on the stuff, they are the ones who get their grade 1s. So I don't want anybody to come to this math class with any fear. If that is the case, join the other integrated math class. I want you to come with an open mind, open heart. I am not going to be annoyed at anyone. I'm one of the easygoing teachers. And one of the things that I don't want you to do is to use my my charisma as a weapon to think that you can, you know, be rude or to step over or to walk over or not to maintain that level of respect. I mean, I can see beautiful colors to black in a jiffy, move from 0 to 100, and I don't even want you to tell you that side, right? I love my students. As a science student, you know, there's a level of discipline that comes with being a science student, and I expect that you guys will display that level of respect, the level of maturity, the level of camaraderie, you know, all those wonderful characteristic traits that comes with being a young scientist. That's what I expect of my students. So no man, I will be gentle with you guys, and that's what I expect. All I can ask of you is for you to do your best. You see, once it is that you have done your best, I can't ask you for no more. So if I get a test and I get 90%, I'm gonna ask you for my other 10% to say, sir, that was the best. I can't kill you. I can't kill you, right? But I really want you guys to just continue working very hard. As I said before, you guys did pretty well last year, and I'm expecting bigger things for this year. Are there any other questions?
No, sir.
All right. So for this class, it's not, as I said before, you're not at a movie theater. You're not, you just sit back and just watch a big screen, and that is it. So you're going to become active learners. So you need to have your notebooks. You need to have your implements, just like you're coming to a face-to-face class. I'm going to try as best as possible to make this sort of interaction come to life. The only thing that I will promise you that will be missing is the sort of face-to-face encounter where I can pass you the class and touch, and I can look into your books, and I can, you know, give you some feedback. No, we're not going to have that in the online class. But when I give you your work, I expect that you're going to be doing the work. And as a result of that, I promise you that things will be fine, things will be well. You don't have to worry about anything at all. You will do just fine. You'll be just fine. 1 minute. All right. So yeah, I mean, I think as we go, we will get there. Okay, so it's now almost 6 o'clock. Let us see if we can hit the ball running. Let's see if we can hit the ball running. I will send you, okay, I'm gonna ask that some responsible person in the class, create a WhatsApp. By the way, let me ask you, let me not be presumptive. How do you prefer to be communicated? Via email or via WhatsApp?
WhatsApp, sir.
WhatsApp.
Okay, great. So I'm gonna ask a very responsible person or persons to go ahead and create a WhatsApp group. I know you're going to say, but sir, we're already in a STEM WhatsApp and in a bio WhatsApp, but yeah, be prepared that each lecture we want their own little WhatsApp. You know, it spells a nice way for us to keep in contact with, you know, core specific students. So I'm going to ask that you, at some point in time, you can maybe, how do we do this? Put your number in the chat, and a responsible person will create some either link or to however it is that you're going to create the group for the integrated math, so that we can all stay connected. When that is done, I'm going to send you an electronic version of your syllabus so that you can have a look at it. I'm also going to get you connected to our online Editasoft platform, but in the interim, this is what we will be doing in the interim. We will come to class, we will sit together, we will discuss mathematics. I don't have a problem with people eating in my class, just don't make the sound of the spoon scraping the pot bottom. But if you have to refresh yourself, just do it and do it discreetly. And this is where I'm going to be starting. I'm going to be starting at Unit 4 within Module 1. Unit 4 within Module 1. And it says, the module says Foundations of Mathematics. And I may not see that. It says Foundations of Mathematics. And we're going to be looking at logarithms and exponents. Logarithms and exponents. Let me just bigify this so that you can all see it. All right. Now, what I want you to do is just pay a little bit attention to this bit of information here. This a raised to the nth power. This a is my base. It's all about the base, about the base, and about the base. This a is in my base position. And this n is in my power position, or I can call it an exponent, or I can call it an index. So it's a power, or I can call it exponent, or if I want, I can call it an index. Now, the plural for index is indices. The plural for index is indices. So we don't say indexes. So the plural for index is indices, and then we can pluralize exponent and call it exponents, and we can pluralize power to call it powers. All right? So this is my base, this is my power. This is my base, this is my exponent. This is my base, this is my index. Any questions so far?
No, sir.
Okay, all right. Now, let us look at the laws. Let's look at some of the laws. And incidentally, the laws that I'm going to go through with you are laws that can be used to answer any question. Matter of fact, if you're going to be doing indices for Unit 2, by the time I'm finished with this topic, consider that topic finished for Unit 2, because I will be going through, and any question at all that they give you on indices, you should be able to answer those. All right. A to the m multiplied by a to the n is equals to a to the m plus n. A to the m multiplied by a to the n is equals to a to the m plus n. Hear what the narrative says. When you're multiplying, bam, bam, and the bases are the same, a and a, then we're going to be adding our powers, m plus n. Then we're going to be adding our exponents, m plus n. And then we're going to be adding our indices, m plus n. So the result becomes a raised to the m plus n. So when you're multiplying and the bases are the same, we're going to be adding our powers, or exponents, or indices. That's law 1. Then the second one says, when you're dividing and the bases are the same, a and a, you're going to say the numerator power minus the denominator power. The numerator power minus the denominator power. So a to the m over a to the n is going to be equal to a to the m minus n. It's the numerator power minus the denominator power. So when you are dividing and the bases are the same, it's going to be the numerator power minus the denominator power. So a to the m divided by a to the n is going to be equal to a to the m plus n. Right? Any questions so far? That's okay?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Good job, good job. Now, this one says a to the negative m a to the negative m, a to the negative m. A to the negative m can be written as 1 over a to the positive m. Oh no, what did we do right there? Look at it carefully for me. Do you recognize that we had a negative power right here, which is in red, I think? We had a negative power. Now, when I invert, reciprocate this term, I'm going to end up with a to the positive m. So you talk about reciprocate. We're not seeing anything to reciprocate, and I know most of you will know it as flipping something. Yeah, man, you're actually reciprocating, you know, because there is an imaginary 1 under this a to the negative m. There is an imaginary 1. But you know that when you divide any number by 1, you get back the same result. So there is an imaginary 1 beneath this a raised to the m power. So when I flip it, that imaginary 1 is going to be moving from the denominator into the numerator. See it yourself? Magic. And then what is here in the numerator is going to go into the denominator, and the sign of the power will change. So see it here, a to the negative m, and down here so it becomes a to the positive m. See that?
Yes, sir.
Yes, sir.
Sir.
All right, good, good, good. For the ones that are answering me, you know, I believe them. The ones that are not answering me, make sure that you are putting in your 2 cents in there. To say, sir, I no follow you. You can do that again for me, please. All right, let's go. A to the m raised to the nth power is going to be equal to a to the m times n. A to the m raised to the nth power is going to be equal to a to the m times n. The narrative says when you have a base, see so, when you have a base a raised to an index, which in turn is raised to another index, then you multiply both indices. Go again, sir. When you have a base raised to an index or power or exponent, which in turn is raised to another index or power or exponent, then the law says, you know what you do? Multiply the 2 indices. So now m times n is going to be equal to mn. That's what this law says. Numero 5. A to the m multiplied by b to the m is going to be equal to a times b, all raised to the m power. A to the m multiplied by b to the m is going to be equal to a multiplied by b, all raised to the m power. The narrative says when you're multiplying and the bases are different, but the powers are the same, you multiply the bases and keep the power. You multiply the bases and keep the power. Let me ask you a question. Did I have to put this AB in parentheses?
No, sir.
Okay. Anybody think I had to?
Yes, sir.
I could just go ahead and just write AB, just remove the parentheses and also AB to the M. That could be okay?
No,
No,
sir.
No, sir.
Why?
Because
So
the m
because
is
then it would be
multiplied
like you're
both
saying
ways.
a times b raised to the m, as in b alone would be raised to the m.
Okay, thank you, Patrice. So yes, very good. We are onto a good start. So my parentheses are very important in this case. Very extremely important. Me say it is as important as you being able to take oxygen on your own. Because if I remove these parentheses, what is going to be happening is that only the B will be affected by this raised power. So what I'll now have is A, B to the M, or A, B raised to the M power. And that would be incorrect. So parentheses are very important. Very, very, very important. All right. The one in a normal here. This is read the nth root of A. The nth root of A. You see there's something in the sleeve of the square root sign is called an M. So that's what we call it, the nth root of A. Then, sir, what if it was a P? It would be the Pth root of A. Then, sir, what if it was Z? The Z root of A, right? But, sir, we normally see it with just a square root sign. There is an imaginary 2 in the sleeve of the square root sign. So that's why 2 we call square. We'll call it the square root of A. Had this been only that sign and the A, it would have been the square root of A. But this one here is saying the nth root of A. I'm going to tell you a secret. Don't tell nobody. It's when I have the nth root of A, what it means is that I'm going to reciprocate the value inside of the sleeve of the square root sign, and it then becomes the index. Sir. I don't catch that one so well. No problem. Thanks for informing me. The nth root of A suggests that the M is sitting on the inside of the sleeve of the square root sign. That's what gives it its name. Just like most of you would have, if not all, would have the name of your father, because that's what gives you your identity. So we speak about the nth root of A. Now the nth root of A suggests that I am going to be, whatsoever is in the sleeve of the square root sign will be reciprocated. And when reciprocated, it now becomes the power. So really, my reciprocated again. No, you know, sir, but we just forget it. No problem. Reciprocate means that you can flip it. So if you have 2 over 5 and you reciprocate it, it becomes 5 over 2. You know, I said, boy, I'm going to reciprocate in that favor, you know, as soon as I start working. But then me, the person bought you groceries. And when you start work, you know, and buy them back 1 bag of groceries, you know. Yeah, I carry them go to the supermarket and say, I carry them go Price Mart and say, pick up what you want. Where I use on Charlie. All right? So that's what me I reciprocate. Right? So the nth root of A suggests that whatever rather is in the sleeve of the square root sign will be reciprocated and become an index, or become the index. All right? So if you thought that was tricky, look at number 7. Not a very cute one to look at, but also not a very difficult one either. This is where the nth root of A to the M. All right, sir, take time, sir. Watch it. If the mth root of A is equal to A to the 1 over M, I'm reciprocating here. It means that the nth root of A to the M is going to be A to the M raised to the 1 over N, because I'm going to reciprocate this right here. So talk truth.
Yes, sir.
Yes, sir.
Very good. So we catch right here, so now. Serving us to the other part then yet. Don't worry about that. We will get there. Oh, but sir, you say when a base is raised to a power, which in turn is raised to another power, you multiply both powers, don't it?
Yes, sir.
See it right here, sir? When you have a base raised to an index, which in turn is raised to another index, you multiply both indices. All right, sir, we're going to max out something. We're going to multiply it out. Come on now. All right, so now what I have is M multiplied by 1 over N. M multiplied by 1 over N. Now when you say a whole number, any whole number can be written as a rational number by just putting it over 1. So really and truly, when you say M, is really 1 rubbishness. It's really M over 1 that you're multiplying. And the M, the numerators will multiply together, and the denominators will multiply together. So 1 times M times 1 is M, and 1 times N is N. So this is what I did right in the third line. Just putting this M over 1 to show you that it is a rational number. That's all I did. And then when I multiply these 2 indices, I'm going to have M times 1, see here, M times 1, which is equal to M, and then I'm going to have 1 times N. 1 times N, which is equal to N. So this here now becomes my final answer. So the nth root of A to the M works out to be A to the M over N. A to the M over N. Me know it's a question. in a smart spirit, but then free to answer the question. Ask the question. Which person is that, guys? Who is seeing this stuff but not really catch it? I don't want to ask me. All right, no problem. Anything raised to the power 0 is going to be equals to 1. Anything raised to the power 0 is equals to 1. Anything raised to the power 0 is equals to 1. Anything raised to the first power is itself. Anything raised to the first power is itself. All right? Those are the 9 laws. Those are the 9 laws. Now, I'm going to give you, you may have to zoom in on your device here. I'm going to give you 10 minutes to read through and try and appreciate, digest those laws for me. 10 minutes, only 10 minutes. I'm going to give you 10 minutes to try and appreciate and digest those laws so that we can move into some of the areas. You may begin. All right, thank you. I'm seeing the numbers going, so I know exactly what is happening. Very good, very good, very good. All right. So I'm seeing one coming so far. Sir, number 7, have me away. Is there any other of the laws that have you weak? Is there anybody else having a problem with 7?
Yes, sir.
All right, Ricardo. Now, let me just say something up front that I didn't say. You can't say to yourself, I know 8 of the laws, I don't need to know the 9th law. Not true. Because sometimes when they give you questions, you have to pick up on 5 laws sometimes, 4 laws sometimes, 6 laws another time. So you don't know which of the laws you have to apply in order to evaluate your questions given on indices. So let me move this screen from this back to this. And let me focus number 7 right there. Number 7 says, let me go from 6. The nth root of A. 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 Anything that is inside the sleeve of a square root sign is going to be reciprocated and becomes the power. Everybody see that?
Yes, sir.
All right. Anything that is inside the sleeve of the square root sign is going to be reciprocated and it all becomes a power. This one now is the nth root of A to the M. The nth root of A to the M. Whatever is in the sleeve of the square root sign is going to be reciprocated and becomes the power. So this is going to be A to the M raised to the 1 over N. Law 4 above says that when I have a base raised to a power, which in turn is raised to another power, I'm going to be multiplying both powers. I'm going to be multiplying both powers. This M is the same thing as M over 1. And when I'm multiplying 2 fractions, I multiply my numerators and my denominator. So M times 1, C to so is M. 1 times N, C to so 1 times N is N. So that's how we get that. Any questions? Is it a little clearer now? Danica, you understanding? Janae, Giovanni, Shante, understanding?
Yes, sir.
Good job.
Yes, sir. Make it, sir.
Is there anybody in the class that still don't follow it? Let me see a show of hands of those who understand all 9 laws. Raise your hand for me, please. $14 of you. 15. Anybody else? Nice. Continue. Nice. All right. So there are 19 of you that indicated that you're understanding. All right. So put your hands down for me now. Take down your hands for me, please. Thank you. Natalie, there is a message on your screen. Can you respond to it for me, please? Natalie Buckley, there's a message on your screen. Can you respond to it for me, please?
Sorry, it's Natalia.
Sorry, Natalia. Yeah, we just see it. These are my item dark. Miss Buckley, sorry. Can you respond to it? All right, thank you. All right, so I had some little stuff to take care of. One of the things I would say to you again, now students, there are times I may need to speak with one or two of you outside of the general class. I will create a breakout room and ask you to join me there, because just like I'm in the face-to-face class and I want to talk to you, I say, come here, come join me right here, sir. I whisper something to you. So I will ask you to join me in the breakout room. So just be alert. All right. I'm happy. I'm happy because you guys are following. I'm very happy. Super excited. You know why? This is 22 minutes to 7 o'clock. And so far it seems as if you guys are alert. No. Watch me now. I'm going to give you a question. No, I'm not going to give you a question. I am going to be working this question with you. I'm going to be working this question with you. And in working this question, I'm going to ask that you give me the undivided attention that I'm requesting. And don't think about what don't think about what I just, the class that you just had. Don't think about it. Think about the math that you're in now. Don't think about the chemistry class and the bio class that went from 1 o'clock to 3 o'clock. Our time. So my question is in blue. My question is in blue. 3 to the second power times 3 to the 6th power all over 9 squares. 3 to the second power times 3 to the 6th power over 9 squares. Then, sir, we just put up on the calculator so I can get my answer 50 times, sir. No. The question is given as an index. They expect the answer to be written as an index. So they expect you to show and apply the laws of indices. They expect you to apply the laws of indices. Watch me, let's go. The law says whenever I'm multiplying and the bases are the same, I'm adding my powers. Whenever I'm multiplying and the bases are the same, I'm adding my powers. A to the m multiplied by a to the n is equal to a to the m plus n. See to yourself? 3 to the second power times 3 to the 6th power is going to be 3 raised to the 2 plus 6, which is 3 to the 8. Sir, that works all the time? We could check it now. 3 squares is this. Bam times bam. 3 to the 6 is this. 3, 1, 2, 3, 4, 5, 6. How many 3s do I have now? 1, 2, 3, 4, 5, 6, 7, 8. And that's how we got our 3 to the 8. See here? So it's 3 to the 2 plus 6 gives me 3 to the 8th power. This 9 squares, I wrote it back. But look at what the 9 squares is going to work out to be now. 9 can be written as the same thing as 3 times 3. 9 can be written as 3 times 3. See here? 9 is the same thing as 3 times 3, which is going to be equal to 3 squares. But watch this trick. This 9 is colored. So is the 3 squares. This 9, I am converting into an index. This 9, I'm converting into an index. You notice that the square beside the 9 don't change. See it yourself? The square here is the same square that is here. The only thing I did was to convert here. So why convert it? It's mostly by a base raised to a power, in turn raised to another power. You multiply the powers. 2 times 2 is 4. So it gives me now 3 to the 4th. Sir, that's why I do it now, sir, because you want the bases to be the same, don't? Absolutely. The bases, once the bases are the same, I can apply the law of indices. Sir, I remember that, you said that when I'm dividing and the bases are the same, you're going to subtract. And the order that you subtract is going to be the numerator power minus the denominator. Am I right, sir? Very good. Watch me. The law says a to the m over a to the n is going to be equal to a to the m minus n. M minus n. So it's going to become 8 minus 4, which is going to be equal to 4. And 3 to the 4th is my answer. 3 to the 4th is my final answer. What I want you to do for me, I want you to take about 3 minutes. I want to take about 3 minutes. And I want you to go through this question that I just did with you. 3 minutes. Wherever you're not seeing, make a notation And after the 3 minutes, you can ask me those questions because I have one final question to ask you about this. Go. All right. How are we so far? Are we okay?
Yes, sir.
Yes, sir.
Yes. I have a question, and I'm going to call upon somebody to answer my question. I told you that I want everybody to be participating. And John Mark, please unmute, sir.
Yes,
How
sir.
are you doing today?
I'm doing fine.
Good job. How many laws did we use to evaluate this question? John Mark alone. How many laws did we use to evaluate this question?
Yes.
Two?
Three.
You said three.
Yes.
All right. Okay. Thank you, John Mark. Giovanni. Unmute, please.
Yes, sir.
John Mark says three. Do you agree with him?
Yes, sir.
Okay. Can you identify those three for me, please?
When initially you add the powers them 2 and 6 when they are multiply with the base 3, then you have when you divide all through.
So this is a first law.
Yes, sir. First order.
Okay. And where's the second one?
When you divide.
This one here.
Yes, sir.
Okay. So is the other law.
And the last part, when they have the 3, when you have the 3 square, and when you have, as in like the 9 part, which we have the 3 square and it's all square.
Right here, so?
Yes, sir.
Very good. Thank you, sir. Very, very, very good. And students, that's all that there is to this integrated mathematics. This night class. Don't worry about it. If you pay attention, you focus on what is happening, you should be good to go. Shouldn't have a problem. I guarantee you 100%. Shouldn't have a problem. All right. Is there anyone in the class now? It's a big class, you know, it's 21 of you. As a matter of fact, it was up to as many as 23 of you. Is there anybody in the class who don't understand what John Mark said, don't understand what Giovanni say, and don't understand what one with a question here? Is there any such person? I'm going to ask you to raise your hand now. Remember, if you sit in class and you don't understand, and you don't say nothing to the teacher, you're stupid. Bad too.
Excuse me, sir?
Mm-hmm.
How many laws I said?
3.
Oh, okay.
What green are you, please?
Excuse me?
What green are you?
Tatiana?
All right, I'm going to ask you to rename yourself for me, please, here, so I can know what I'm referring to. Thanks, son. So if you're not understanding a city Mr. Shan class, and you don't say, sir, I'm not understanding, stupid. Stupid decision. Stupid decision. But you see, if you're not understanding, say, sir, I don't have a clue where I'm going. You are sensible. Let me tell you, Javier. Let me tell you, talk to me outside of class. Don't sit and say, sir, I don't want to disturb the class. That is unacceptable. Talk to me. Talk to me. All right. But this is very good though. I'm very, very, very encouraged in the night. I'm very encouraged in the night. All right. Let me see how many of you will get this right. I'll be calling on somebody else. You don't know who I'm going to be calling on, so make sure that you do this question. I'm giving you, we're just learning the topic. So I'm going to give you 3 more minutes to do number 2 for me. On your mark, set, go. Natalie?
Yes, sir.
Oh, no, I was saying that if you could mute, your music is tempting.
Oh, sorry, sir. Sorry.
All right. Eeny, meeny, miny, mo. Let us see which one. Tanil, unmute for me, please.
Yes, sir.
All right. Tell me what it is that you've got for your answer right there.
Okay, sir. I did it 2 ways.
Okay. Both ways give you the same answer.
No.
But give me the
I'll
right way then.
I'll go with the simplified version of basically what you did first.
Okay.
Of the example. Okay, sir. So when I did everything, I got 2 to the negative 6.
You got 2 to the negative 6. All right. Okay. All right. You stay right there, so don't say another word. Amelia. Unmute for me, please.
Yes, sir.
She said 2 to the negative 6. You agree with that?
So that's not what I got.
What did you get?
I get 4 to the raised to the 7.
We got 4 raised to the 7th power. All right, no problem. Sharika.
Yes, sir.
What do you get?
2 raised to the negative 8.
2 raised to the negative 8. Blow out 3 different somebody, 3 different answers. All right, no problem. No problem. I love it. Shante, what say thou?
Sir, I got 2 to the negative 4.
2 to the negative 4. 4 persons, 4 different answers. Anik. No. Aniki, right, Aniki.
2 to the negative 4.
Say it again, honey.
2 to the negative 4.
Oh, so 2 of you give me 2 to the negative 4. All right, all right. So I'm willing to go with Chanel. Hey, Miss Whitfield, I called your name yesterday. Go ahead, Chanel. Tell me what it is that you get for your answer.
Sir, I actually haven't finished it as yet.
You know what that costs for now? You owe me curried lobster lunch for not finishing my work. And I will collect that tomorrow. Miss Natalia, what say thou? Did you try that one for me, Natalia?
Nathania or Natalia?
Natalia Buckley. Okay, Nathania Hall, answer me please.
2 to the negative 4.
2 to the negative 4. All right, so 3 persons, 2 to the negative 4. I don't know if they are correct. Let us check. We are going to check. 2 to the negative 4, is it? 2 to the negative 4 is correcto. 2 to the negative 4 is correct. Now, I'm giving you a minute to look at that answer. I'm giving you a minute to look at the answer. I could give you 2 minutes to look at the answer. Now, when you look at the answer, for those of you who got something, you see the person that got 2 to the negative, 2 to the 7th. Somebody said something with 2 to the 7th. Can you talk to me, please? What was the answer? Don't shy away from me now. Just talk to me. All right.
Yeah, I said 2 to the negative 8.
2 to the negative 8, yeah, but somebody said something with 7. All right. Look at this one, please. I give you 2 minutes to just look at it. And I'll come back to that one. But very good though, guys. for those of you who did not get the correct answer for this one, at least you tried. And I wanted a person who got 2 to the 7 something to talk to me, because I think I know where that person got the 2 to the 7. Never mind. Give you another 2 minutes. Are there any questions? Hello? Are there any questions? All right. There is a question that I well, not a question, it's a statement. All right. So it's in mathematics, we are really positive thinking people, and we never normally write our answer as a negative index. So it's the negative 2 to the negative 4. We will write our answer as 1 over 2 to the positive 4. Then, sir, if I wrote it as 1 over 2 to the negative, sorry, if I wrote it as 2 to the negative 4, would that be incorrect? No. But just like how you would cook your rice and peas and chicken and you won't throw your sorrel drink over it, even though you can eat or drink, because it's well cooked. But presentation-wise, we normally leave our answers a positive index rather than a -1. Very good. Excellent. All right. So we're gonna speed up things a little bit. I want to give you guys let's see what goes here. All right. I'm going to speed up. So what I'm going to ask you to do is maybe not 5 minutes this time, but I'm going to give you about 2 minutes to start that question. Can you start for me, please? We want to work quickly and accurately. Who has gotten an answer?
Me, sir.
All right.
Finish,
What's your,
sir.
good. And what's your answer?
Sir, 2 to the negative 2, but we should leave it the answer in a negative index, so 1/4.
1/4. Okay. All right. All right.
So I got the same
I
answer.
got 2 to the negative.
Very good. Very, very good. I'm very encouraged, guys. This is very good. Excellent work. Excellent work. Excellent work.
Sir.
Yes, please.
Sir, is it okay if I put 1/2 plus 2? Is that still right?
No,
But
because no, it has to be multiplication because there's no law for indices that speak about plus and plus. It has to be multiplication.
Okay, sir.
All right. All right. All right. Now, come on now, Sir Shand. All right. There goes number 4. 2 more minutes. Guys, I want you to try this, you know. Those of you who are not following, try it. Try, try, try. Go ahead.
Sir, the numerator is 81, right?
Yes, there is. What's the answer? What's the answer? What's the answer?
Sir, I got
To the
3.
first part.
Of 1, which is 3.
Somebody said 3?
Yes, sir.
Yes, sir. 3.
Yes, sir.
I don't think that's correct. Anybody gets a different answer?
3 to the 24th.
3 to the 24th? Fox, what you saying? 3 to the 24th?
Yes, sir.
Okay, I don't think that is correct either.
I got 3 raised to the power of 4.
Very good. Very, very, very good. Very good, guys. No, you guys are really working. You really are working. That's very good. Very good work in the night. All right. I'm gonna give you.
Excuse me, sir.
Yes, hon. Go ahead.
Sure, I have a little question. I got it right in sir, but I still wanted to ask. In questions like this, when it can result in 81 over 27 and get the 3, would it be can you leave it like that, or should you put it at the 3 raised to 3, also raised to 2 over 3 raised to 3, and continue? You're gonna get the same answer, sir. So does it matter?
Janice, it sure does. And let me just reiterate that point again. Said it earlier, but let me say it one more time. Because the question is given on indices, anyone who uses a calculator to put this over that, 81 over 27 equals 3, will get 0 mark. You have to show the steps in applying the laws of indices. You must apply the steps, the law of indices, in order to get the stuff done up. You must. If not, you are going to be wrong. So it's all these steps here, Denise.
Yes, it, sir.
Very good. All of these must be done so it is that you can show the laws. When you're multiplying on the basis that is in added powers, that's one law down here. And when you divide it to subtract the powers, that's another law. And another law, the third law says anything raised to the power to the first power is that in itself, right? So you have to do that. All right. Very good question, though.
So I did it both ways. I was just making sure.
And guess what? And you are right. If you're not sure, you ask, and I'm proud of you. Very nice. Do me a favor. Here goes number 5. Start for me, please. 2 minutes. What is the answer? Is there no answer for this one? Is it that you got bold?
Sir?
Yeah.
Okay, sir. So I know that when you reach the last step, the concept, when it is division, is supposed to minus the indices, right? So the numerator, the base numerator and the base denominator are different. So I'm wondering if I should put them in brackets and then put the indice outside when I minus them.
Oh, Tanil. Oh, my Lord. Whether or not you're right, I am just proud of your level of thinking. Finish doing that and tell what is up for your final answer, please, Tanil. Anybody else got an answer? I had to put this one there because I don't want anybody to think that it is going to be hunky-dory. So that's what it looks like.
Sir? Sir, I stopped at 2 raised to the 8 over 3 raised to the 4.
It can go down some more. So if this is a 5 marker, they may get about 3 marks out of it. Because remember, 2 raised to the 8th power, can be written as something to the 4th power. Because remember, 2 times 4 is 8. And then on the denominator, which is what they can use as a hint. So since the power in the denominator is 4, see if you can get a 4 out of that. So that you can, as Tani says, you can raise everything to the 4th power. So I had it as 2 squares over 3 to the 4th power, and I'm now putting 2 squares is 4 and putting 4/3 raised to the 4th power. 4/3 raised to the 4th power. Any questions? How we stay? Talk to me, man. Talk to me, talk to me, talk to me, talk to me, talk to me. Shanti?
Yes, sir. No questions, sir.
Okay, good. All right, I'm going to give you one more, so the last digga one, before we do a little bit more housekeeping, and we'll call it a night. One last digga one. Because life is not always, when we're doing mathematics, with just numbers to get a final answer. We have to work with variables. Variables. Here goes one. The last one we're going to do for tonight. X to the 4th raised to the 5th power multiplied by x to the negative half. I want you to simplify that for me, please. 3 minutes.
Finished, sir.
Wow. What did you get for your answer?
Sir, I got x to the 22nd power.
X to the 22nd. Okay, what did you get for the answer?
X to the 22nd power.
Okay, anybody else? John Mark, what did you get?
So I'm not sure.
All right. So for those answers that I've received so far, I'm going to ask that you look back at it. Look back at it. Apply the laws of indices up front. Look back at that one. There's something that you are missing. Final question for the night. You can't do this for the final one for the night. Now, man, look back at it, please. In 60 seconds.
Sir?
This one.
I think I see the mistake. I got x to the 20.5 power.
You're much closer than you were before. You're very close. Very, very close.
19.5.
Bam, bam. Here you go. Chanel, you remember it's a minus a half, you know. It's a minus a half that you have. It's a minus a half you have. So what you did, Chanel, was to add 20 to a half to get 20 and a half. So you have to subtract. So it's going to be 19 and a half or 39 over 2. All right. Is the WhatsApp group set up?
Yes, sir.
Yes, please. Go ahead.
That's not what I did to get the answer.
What did you do?
So I got, so I'll explain this. So first, I have x, and then to the power of 4 times the power of 5, and that would be
X to the 20.
Yes, and then I got, so you get x to the 20th power times x to the negative half. And then I got x to the 20th power minus the half, and I got 18 to the, wait, what? I got x to the 19.5.
Teacher, same difference. Same difference.
Sir?
Yes, yes, please.
Suppose the square root of x raised to the 39.
The square root?
Yes, sir.
No, not square root. Not square root.
Sir, not square root?
No. Not the square root. No, not square root. Square root won't come in play here.
Sir, so the half would make it, suppose, like a half, like 39. You understand what I'm saying? To the half.
I understand exactly what it is that you're saying. But remember, no, you know, it's not a positive a half, and it's a negative a half. So it's going to be the square root of that. So what it is that you're asking is if you can rewrite your x, if you could rewrite your answer in a different form with the square root.
Yes, sir.
And what would be your answer? Give me the answer if you were to do that.
The square root x, the square root, then you have inside the square root you have x raised to the 39.
Yeah. In that case, yeah. When you convert x to the 39 over 2, that's what you'll end up getting. Very good.
All right.
All right, cool. All right, so I'm stopping here for tonight. I'm going to ask to be added to the group because I want to send you what it is that we looked at tonight, so you can go back through the document on your own. In addition to that, I want to get a feel from you tonight. How was this very late night class?
They're okay.
Can you repeat again?
That was
All
okay.
right.
Wasn't as bad as I thought.
Okay. No, my question was, I want to get a feedback as to how this very, very, very late night class was. So I want to get some feedback.
Sir, I enjoyed it.
You enjoyed it. Good, 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 good. Anybody else? John Mark, what say you? Giovanni, Janae?
Sir, it was
Sir,
okay, but I'm hungry.
What's your? All right, make some food next time here. All right, never mind. All right, so I thank you for coming out. As I said before, once I'm added to the WhatsApp group, I'm going to be sending out some stuff for you. You know, to be honest with you, if I were to give my own assessment, I'm excited. When I say excited, I'm excited for what is to come. I'm very, very excited for what is to come. Yes, Giovanni, I said that. Very, very excited for what is to come. And I really am going to be asking that you keep up the same energy. The energy that you keep up tonight, I'm going to ask that you maintain that energy for the whole semester, for this semester, next semester, for the whole school year. I guarantee you will reap success. All right? I see you on Friday again for class. And I'm going to ask that you be good. Please don't just sit down with the notes that I'm going to be giving to you. I want you to go through. I want you to look at it. I want you to make the jottings on it. And I want you to come back to class and say, sir, I understand everything, or sir, I don't see something. I don't want you to make cobweb lick up the notes in your phone. All right? So if there's no other question,
Sir.
Yes,
Sir.
please.
I don't get number 6, sir.
You don't get number 6? What you don't get it number 6? What in number 6 that you're not seeing?
So how you get the 40? We do cross multiply?
Find the LCM. Put this over 1. LCM is 2. 1 into 2 goes 2 times, and 2 times 20 is 40. 2 into 2 goes 1 time. Watch me. There's a 1 over this 20, you know. And 1 into 2 goes 2 times, and 2 times 20 is 40. 2 into 2 goes 1, and 1 times -1 is -1.
Yeah, so you could just reciprocate the x to the -1/2 and just move on from there.
Yeah.
You get the same answer?
Yes, sir, that is how I get the x to 19.5.
Guess what? Me now go down there, so I'm not going down there. It's the same translation. So as long as Shanshan, it is mathematically sound, you can go through with it. Very good. Very good. That too can work.
Sir.
Yes, please.
Sir, but like go all right, up at the top where it's the x20 times the x1/2 something. Couldn't you just like the -1? Couldn't you just like multiply all the bases? But then that would have been different.
The bases are the same, so you're adding the power. So what it technically means, you know, is adding 20 to -1/2. You know, if I have $20 and I go 50 cents out, I have $19.50. See right there, so 19.5. That's all I'm doing. All I'm doing inside here is Australia to working out. That's why I have equivalent signs here. But when
Sir, but I thought that we were supposed to reciprocate the -1/2. That's why, and turn it to something positive.
No. You don't reciprocate the questions. The question in between. You only reciprocate like the final answer. So you keep it as it is until you reach your final something. Then you do some conversion.
Okay, sir. That's okay.
Man. That's fine. That's
Thank
fine.
you.
Bless up. Have a good one, guys. Be safe, protect yourself, and see you on Friday. All be well.
Okay, bye, sir.
Bye,
Bye-bye.
sir. Same
You
to
too,
you.
sir. Bye.
Yeah, take care of you, man.
Sir,
Mm.
sir, I can check to see if you were added to the group.
Oh, yes, real talk. I feel the phone trembling. Yes, I have been. Thank you. Thank you. Thank you. Thank you.
Okay,
All right, later, guys. I'm on phone.
Sir,
Please.
sir, everybody can leave, sir, but you can scroll down. I want to try number 7.
No, man, I'm going to send number 7. That is going to be homework.
Okay.
Yeah,
Okay.
cool.